This is the topic or the chapter 2 review for pre-calculus. So looking at number 3, give the zeros if they exist. The denominator cannot be 0. So to find the zeros of this function, I take the numerator, x squared minus 3x minus 18. I set it equal to 0. And that's going to factor to x minus 6 times quantity x plus 3. So this gives me x equals 6, x equal negative 3. And that's that problem. And I need another sheet of paper here, it looks like. So didn't leave myself quite enough room to write the answers right on there. So the next part, we're using f of x equals 3x squared plus 5x. And for number 4, I'm supposed to find f of 3i, which means I'm plugging in 3i for x. So 3 times 3i quantity squared plus 5 times 3i. And this is going to be 9i squared plus 15i, or negative 9 plus 15i. And number 5, we're supposed to find f of x plus 1. So that's going to be 3 times x plus 1 quantity squared plus 5 times the quantity x plus 1. So first I need to multiply that x plus 1 out. Remember, when we do that, we're going to get a trinomial, because I can't do x squared plus 1. I have to do x squared plus the middle terms, 2x plus 1. And then this is 5x plus 5. So 3x squared plus 6x plus 3 plus 5x plus 5. Now I combine like terms. Get 3x squared plus 11x plus 8. Okay. Number 6. Negative 4 is a 0 of the polynomial. P of x equals 3x cubed plus kx minus 2. And if negative 4 is a 0, that means that the ordered pair for negative 4, 0 works in that equation. So what I can do is let y, or p of x, be 0, and let x be negative 4. X be negative 4, sorry, and solve that equation for k. So it looks like I have 3 times negative 4 cubed I'm not sure, I think it's negative 64, and then times 3 is negative 192, plus k times negative 4 minus 2 is negative 194 minus 4k, so 194 equals negative 4k. K is 194 divided by negative 4 is negative 48.5. As a fraction, it's negative 97 over 2. Okay. So on this one, looks like my zeros are at negative 2, 0, and 2. And it passes through the point 1, negative 3. So f of x equals a times the quantity x plus 2 times the quantity x times the quantity x minus 2. And then I plug in -3 here equals a times 1 plus 2 is 3 times 1, and 1 minus 2 is -1. So -3 equals, I certainly did not intend for that to happen, but -3 equals -3a. Therefore, a is 1. Therefore, f of x is x plus 2 times x minus 2. Okay. Number 9, sketch the graph of f of x equals x to the 4th minus 3x cubed minus 4x squared. Well, this has a greatest common factor, which makes it a lot easier. I just factor out an x squared, and I get x squared minus 3x minus 4. And then that is a trinomial that factors. Go to our factor puzzle if we need to. It's x minus 4 times x plus 1. So my zeros are x equals 0, and that's a double root. X equals 4, and x equals -1. And we just graph that. -1, 0, and 4. And it is a quartic, and it is positive out front. So it's going to open up, which means my arms are up in the air. So, and x is a double root. So like that, and then back down and back up. Something like that. Oh, you can't see it. There you go. My zeros are at -1, 0, and 4, and 0 is a double root, so I do the tangent thing at a double root. Number 10, we have 5x cubed minus 2x squared plus x minus 2 equals 0. And we're supposed to find the sum and the product of the roots. And a lot of you had difficulty with this on the quiz, but basically, the sum of the roots is the opposite of b over a. And the product of the roots, didn't mean to write x, sorry. Sum of the roots, and the product of the roots, remember, it's not c over a. It's the constant over a. And it's because this is an odd degreed function, it's actually the opposite of the constant. And so the sum of the roots would be 2/5, and the product of the roots would be 2/5. That's interesting. So that's what we get for that. Okay. Number 11, find a cubic equation with integral coefficients, and the roots are 2 and 1 minus I, which means the other root we have to know is 1 plus I. Okay. So remember, what I do is I take these two roots and I write the quadratic function. The sum of those roots, 1 minus I plus 1 plus I, is 2. And so opposite of b over a equals 2 over 1. The product of those roots would be 1 minus I times 1 plus I. And so when we multiply that out, we get 1 minus I squared, which is 2. So C over A equals 2 over 1 also, which means that A is 1, B is negative 2, and C is positive 2. And so we take x minus 2 and we multiply it by x squared minus 2x plus 2. And we get x cubed minus 2x squared plus 2x minus 2x squared plus 4x minus 2, or x cubed minus 4x squared plus 6x minus 2, 0. And the last one on the non-calculator portion is to solve 2x cubed minus 7x squared minus 19x plus 60. And factor by grouping is not going to work. It is not of the quadratic form. And so what we need to do is use the rational roots theorem. It's going to be an extensive list, plus or minus 1, 2, 3, 4, 5, 6 goes in, no 7, no 8, no 9, 10, 12, 15, 16, 17, 18, 20, 30, and that's about it, I think. Now we just trial and error. It's a long list of possible roots. We just trial and error it as to what's going to get us a denominator of 0, because if the denominator is 0, it is a factor according to the factor theorem. And I'm having a tough time with that on my, I'm cheating, actually. We're going to try negative 2. Let's see, that would be 2, negative 4, negative 11, 22, right? That would be 3, but that would be 6, not 60. So let's try negative 3. So 2, negative 21, negative 28, 8 times 3 is 84, minus 19 is 65. It's not going to work. This is going to be it, but let's try negative 1. 2, negative 2, negative 9, 18, negative 1. No, that's not going to work. See. Well, I am not getting this to work out. I'm cheating. I'm using my graphing calculator, and it doesn't seem to be working out. I'm sure that the one on the quiz is one that will factor, that we can use the rational roots theorem to determine. I'm sorry, the one on the test will. And I will try to come up with a substitute problem for this. Sometimes if I just go in there and I change one of the signs, it changes the whole ball game. And that doesn't seem to be happening here. There we go. No, that didn't work. Anyway, I'm not going to extend the life of the video trying to figure that out. We will come up with a substitute problem on Tuesday, or on Monday, sorry, and go from there. And then that brings us to the calculator portion of the test. So this is graphing calculator portion, and I'll have my graphing calculator here. And for this first one, we could just use synthetic division and figure it out that way. But since it is, I am able to use my calculator. I'm going to put that into my calculator. It's 2x to the 4th minus 9x to the 3rd plus 2x squared plus 9x minus 4. And it doesn't matter what the graph is going to look like, because I'm just going to find f of negative 2. And so I go to second trace, which is calculate, and I want it to calculate a value. and I put in the value -2 for the first one, and I get 90. So the answer is 90 for that one. And then I just put in 3, and I don't have to go back to second, trace, value. It'll stay there as long as I don't press any other buttons. So if I plug in 3, I get -40. And there you go. Those are done. And again, could have used synthetic division for that. Could have just plugged it in and figured it out that way. But like I said, it's a calculator problem, so we move on. Number 3, a rectangular enclosure subdivided into 3 congruent pens is to be made using a barn as one side. Gosh, this problem looks familiar. A barn is one side. Here's the barn. And 3 congruent pens. So, oh, that would be 2. So we're going to need to draw in 2 lines there. Here and here. And 300 meters of fencing. So again, we want to make the multiple parts x, and so this would be 300 minus 4x, because that's the amount of fencing I have and what I've used. Find the value of x that gives the maximum area for the enclosure. So the area of this enclosure, a of x, equals x times the quantity 300 minus 4x. Even though it's not asking for it, it is helpful to know the domain so that when I set up my window, I have an idea of what my domain is to set up my window to find where the maximum is. So the domain is going to be 0 to 75. So now when I jump to my calculator, I go to y equals, and I do not need to multiply that out. It's x. Oh, wait a minute. No, this is fine. X times the quantity, 300 minus 4x. Okay. And I don't know, zoom 6. And obviously, we said we need to adjust our window. Let's do -25 to 100. Have it count by 5s. And let's do -100 to do 3,000 and have it count by 100. Oh, not high enough. Still not seeing that vertex up there. So go back to window, and I need to change my Y max to maybe 8,000. And there it is. Okay, so now I go to second trace, which is calculate. I want it to calculate that maximum. So I come over here and I give it a left bound. I come over here and I give it a right bound. I come back here and I give it a guess. And I get 37.5. And 5625. Okay, so to answer this question, we should label 37.5 meters, and the maximum area is 5,625 meters squared. What I hesitated for when we went to the calculator is I could have also, this doesn't really require a calculator like the cubic function does. Excuse me. That's going to be minus 4x squared. We could have used the opposite of b over 2a, or negative 300 over negative 8, and that would have given us the 37.5 also. And then just plug that in to find what the maximum area is. Since it is a calculator problem, use my calculator. Number 4, find the smallest positive root of negative 3x to the 4th plus 2x to the 3rd minus x squared plus 5x plus 1 equals 0. So again, it is a calculator problem, so I'm going to plug that into my calculator. Negative 3x to the 4th plus 2x to the 3rd minus oops, minus x squared plus 5x plus 1. And I'm just going to hit zoom 6, and I see that the smallest positive root is going to be over here between 1 and 2. And so I'm going to do second trace, calculate the 0. My left bound for that is going to be above the axis. My right bound is going to be below the axis. And then I have to tell it what I want. And my answer is x equals 1.400 something 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 something. So 1.4 would be the answer. So we're supposed to find the smallest positive root, and that would be it. Number 5, if p of x equals 4x to the 4th minus 4x minus 3, explain how you know that p of x equals 0 has at least one real root between p of 1 and x equals 1 and x equals 2. And then use your calculator to find each root to the nearest 10th. Okay. So again, we want to plug that into y1, x to the 4th, sorry, 4x to the 4th. Just looking down at the next problem. Minus 4x minus 3. And what I'm going to do is I'm going to have it graph that. And then I'm going to do second trace calculate the value, which is 1, and I'm going to plug in 1, and I get negative 3. So p of 1 equals negative 3, and I'm going to plug in 2, and p of 2 is 53. So since p of 1 is negative and p of 2 is positive, I have to have crossed the x-axis. And if I cross the x-axis, then there's a root in between there. There's a 0, there's an x-intercept, a root, whatever you want to call it. Okay. And then to find those roots, I'm actually going to go to zoom 4. It's going to give me a slightly better picture of those zeros. And then second trace, calculate the zeros, which is number 2. And for this left one, my left bound is going to be above. My right bound is going to be below. My guess is right on. And looks like I'm getting x equals negative 0.6, because I think the directions say round to the nearest 10th. And then to find the other root, same thing, second trace, calculate the 0. This time my left bound is going to be below the axis. My right bound is going to be above, and give it a guess, and it's telling me X equals 1.17, so that would be 1.2. Okay. Number 6 says determine where the graphs of the two functions intersect or are tangent. And we have y equals x to the fourth minus 3x to the third, and y equals 2x minus 6. I don't know that I've shown you how to do this on the calculator. I think we did with lines, but not with this. So what you can do is you can put in x to the fourth minus 3x cubed. I didn't get a minus sign in there. And then in y2, put 2x minus 6. Try zoom 6. And there are your points of intersection. Okay. And then to find those points of intersection, we do second trace, which is calculate, intersect, which is 5. And again, I just need to move my cursor down here and actually press enter, press enter, press enter, and I get the point 1.25, so 1.3, comma, 3.48 would be 3.5. So there's one point of intersection. To find the other one, I go back to second, trace, calculate the intersection. And again, I've moved my cursor over to that, and I hit enter, enter, and I get the 0.30. And could have surmised that. I saw that one on there. To do this by hand, you would set these equal to each other. X to the fourth minus 3x cubed equals 2x minus 6. And then you would 3x cubed minus 2x plus 6. And then you would use the rational roots theorem and figure out a root, which is obviously 3. And then you would divide that out, and you'd be down to a cubic that would have to, I don't know that the cubic would factor because I don't know that we're seeing any other roots. So last problem. We have a square with sides length x are cut from the corners of a rectangular piece of sheet metal with dimensions 15 by 36. So this is 15 centimeters by 36 centimeters. And I'm going to cut out a corner of the same size, right, to make an open top box. So these are all x, which means that this from here to here is 15 minus 2x, and this one from here to here is 36 minus 2x. And when I fold those up, the height of my box is going to be x. So the volume, V of x, is x times the quantity, 15 minus 2x, times the quantity, 36 minus 2x. My domain, again, I don't know. They're not asking you to state the domain, but it helps. Again, with my window, it's going to be 0 to 7.5. Because when I solve this one, I get 7.5. When I solve this one, I get 18, but it can't be 18 because that would negate the other one, and we'd have a negative volume. No negative volumes allowed. So we go to our calculator. We put into y1, clear out what I have from the previous problem. And so y1, I'm going to put x, and there's no need to multiply this out. It's going to be x times the quantity, 15 minus 2x, times the quantity, 36 minus 2x. And we are going to look at that graph. And I don't know. Need to do some adjustments there. So I'm going to go -5 to 15. And then I'm going to go -100 to, I don't know, 5,000. Let's try that and have it count by 100. Oh, I screwed up there. -515. Well, that's a problem. Oh, I overshot the maximum there by quite a bit. Let's see, let's change that just so that we have a better window to 800. See if that gives us a little bit. Well, oh, now I undershot it. One more time, let's make that 1200. Do I hear 1200? Oh, there it is. It's a nice little picture. So second trace, when you calculate the maximum, give it a left bound, give it a right bound, give it a guess, and we get that x equals 3.3, and the maximum volume is 814.99, which technically, if we're rounding that to the nearest tenth, is 815.0. And then some units on here. This is centimeters cubed. That's our maximum volume. And 3.3 centimeters is the value of x that's going to give me that maximum volume. Okay, and that is all.